Balancing chemical reactions. Combustion of organic compound and products are carbon dioxide gas and water. So we have 2 carbons on the left side. We should put coefficient 2 here. We have 4 hydrogen atoms, so we should put coefficient 2 here. Now let's go to oxygen. So we always start with carbon if we have carbon, hydrogen, oxygen, or for example carbon, hydrogen, nitrogen. We should start with carbon, then hydrogen, and always leave oxygen until the end. So let's look at oxygen. 2 times 2, we've got 4 oxygen atoms here, plus 2, 6. 6 oxygen atoms on the right side, and to get 6 oxygen atoms on the left side, we should put coefficient 3. Now we have 3 times 2, 6 oxygen atoms on the left side, and 4 times plus 2, 6 on the right side. Next reaction, also organic compound and products are carbon dioxide and water, combustion. So let's start with carbon. 12 carbons, so we should put, I will use pencils. We should put 12 here. 22 hydrogen atoms, so, and here we have coefficient 2, so 22 divided by 2, 11. We should put 11 here. Now let's calculate oxygen. 12 times 2, 24, plus 11 oxygen atoms in water. So we have 35 we've got 35, which is odd number. So when we have odd number of oxygen atoms on the right side, let me show you some trick. So let's pretend we don't have these 2. I'm hiding these 2. And we have 35 oxygen atoms on the right side and just 1 oxygen atom here. So if I put coefficient 35 here, now this reaction is balanced, right? 12 carbons, 22 hydrogens, and 35, 24 plus 11, 35 oxygen atoms. But we cannot forget about these 2. So when I open these 2, it's the same like I multiplied number of oxygen atoms by 2. So I should multiply all other coefficients by 2 except of coefficient in front of oxygen, because this one I already multiplied. So I should multiply by 2. 12 times 2, 24, and 11 times 2, 22. So this is my final balanced equation. And I cannot reduce because I cannot divide 35 by 2. The next one. C12H22O11, again combustion, the same products, carbon dioxide and water. Let's start with carbon. 12 carbons, so we should put 12 here. 22 hydrogen atoms, so we should put 22 divided by 2, 11. We should put 11 here. Now let's count oxygen. We have 11 plus 2 on the left side and 12 times 2, 24 plus 11 on the right side. So this 11 and this 11, right, balance each other. So we need to balance 24 using just this oxygen. In other words, we've got 35 on the right side and 13 on the left side. But we don't want to touch this. We don't want to put any coefficient here, because if we put some coefficient here, we should change this, we should change that, and it will start all over. So we are not touching this. We should subtract 35 minus 11, and we should only balance 24 oxygen atoms using this O2. 24 divided by 2 will give us 12. And we keep this 12 and this 11. Now it's all balanced. Let's check. 12 carbons, 12 carbons. 22 hydrogen atoms, 22 hydrogen atoms, and 11 plus 24, 35 on the left side, and 12 times 2, 24 plus 11, 35 on the right side, also balanced. This next equation contains products are carbon dioxide, water, and elemental nitrogen. So again, let's start with carbon, continue with hydrogen, then nitrogen, and let's leave oxygen to the end. So 6 carbons, we need to put coefficient 6 here. 7 hydrogens, we cannot divide it by 2 and get 3.5. So we need to put 7 here. If we put 7 here, we'll get 14 hydrogen atoms. So we need to put 2 here, and this changes our number of carbons. So instead of 6, now we should put 12. Okay, carbon and hydrogen are balanced. Now let's look at nitrogen. 2N and 2 balanced. Now let's look at oxygen. So we've got 2 here. 12 times 2, 24, plus 7, 31. 31 again, odd number. And again we can use this little trick. So I'm hiding this 2. We can put coefficient 31 here, but we cannot completely forget about this 2. So when I put this 2 back, it means I multiplied number of oxygen atoms by 2. So I have to multiply all other coefficients by 2 except of this one, because this I already multiplied. So instead of 2, I will have 4, right? 31 stays. I don't change it. Instead of 12, we should write 24. Instead of 7, we should write 14. And we should add 2 here. Now it is balanced. Next reaction. 1 barium, 1 barium, balanced. 2 chlorine atoms, 2 chlorine atoms, balanced. Oxygen, we've got 6 on the left side and just 2 on the right side, but we can easily balance it by putting coefficient 3 in front of oxygen. Now it is balanced. And final reaction, aluminum and sodium hydroxide. We have one aluminum on the left side, one aluminum on the right side, balanced. One sodium and 3 sodium atoms here, so we should put 3 here. Now oxygen is balanced, 3 oxygen and 3 oxygen here. Hydrogen, we've got 3 hydrogen on the left side and 2 on the right side. The only thing we can do, we should again use this little trick. We are hiding these 2. If we put coefficient 3 here, now hydrogen is balanced. Then we are returning this 2 back. Now we have 6 hydrogens, so instead of this 3, we should use 6. Right? 6 sodium hydroxide, meaning we should multiply this by 2 and this by 2 also. Now it is balanced. So here we have a lot of different cases, and always start with carbon, hydrogen, metal, then polyatomic ions, and then finish with oxygen, elemental hydrogen, elemental nitrogen if you have them.